All right, this is the DM Alumni workshop. We're going to talk about better understanding your data, and if you have customers, your customer data. We're going to read some emails from my mother, and we're going to talk about automating spreadsheets. Okay. First things first, here's the data. I already explained it. Sorry if you didn't catch that on the video. Moving on to better understanding your data. Descriptives and explore. We're going to figure out who we have in our data. You should see something like this come up, and now we can just understand the distribution of who we've got. So we could throw in marital status, gender. Those are things I'd like to know. You know, distribution of males versus females. Roughly what the yearly income is we're looking at. I'm just going to throw in some stuff here that I think would be good to know. Number of children, not so interested right now. Education, occupation, whether they own a home, not so cool. Let's see. Age, I'd like to know about that. And the average amount spent. That'd be interesting to know. Let's go to plots. I'll slow down. So these are the ones I'm going to look at. You can look at whatever you want, or you can follow along exactly with me if you like. Again, that's marital status, gender, yearly income, age, and average spending. Is that readable up there? Roughly? Not really? No?
That's okay.
All right. If you guys want, you could move over here, whatever you want. Except then you'd be looking through each other's heads too to see the screen. Okay, I'm going to go to plots. And I'd really like to see a histogram. I'm not so interested in the stem and leaf, but I'd love to see the histogram. That'll show me the distribution of responses, the values I have. I'm going to hit continue. That was in plots. And I just want to see plots for now, not both, just plots. And okay. Again, slow me down if I'm going too fast. It's going to run. And here we have it, marital status. I think this is just married versus single. So single would be the 1, married would be 2, roughly equal. This is a box plot, so ignore that for now. We only have 2 values. Another histogram. This is gender, very equal for male versus female. I believe the male is 1, the female is 2. Another box plot. Here we go. Income. Somewhat standard distribution for income. We always see a tail to the right, I guess. Most people make around 50,000, and then very few people make more than 100. Count your blessings. Nice box plot. This is a good one. You can see the mean made, maybe that's the median, I can't remember. The mean or median made is just above 50,000 with 1 standard deviation out to the box here and 2 out to the line here, and then these outliers beyond 2 standard deviations who are making more than 150. These guys are outliers.
Is it the standard deviation or is it the quartiles? Specifically box plots.
Maybe it's quartiles. Thank you. Keep me honest. Thank you. Quartiles. You got that. All right. Quartiles. Depends on who you ask. I've Googled it. Yeah, I've seen both.
Because usually what you plot is the IQR, right? 1.5 times the quartile range.
Oh, cool. Good to know. Okay. Quartiles. I'll have to fix that on my slides when I'm teaching it. All this time, people thought I was telling them the truth. Okay. And I always believe in it. Okay. Now it's online. Truth's out. James has no clue what he's talking about. I'll edit that out. No, I won't.
We're missing 17 seconds.
Let's see. Age. Wow. We have some really old customers. I mean, again, this is fabricated data, but we have, what is that, like 96 years old up there? 95?
Well, but it does reflect what's happening with people living longer. Right?
It is. We have a lot of people over 60 purchasing stuff at our sporting goods store.
You bet.
Oh yeah, that's right. They're still biking and hiking, and rock climbing and hang gliding. Saw this guy the other day just jump off a cliff, whee, with a hang glider. It's amazing. I was up on the cliff with him, but I wasn't jumping. Okay, here we are on average spending. Wow. Most people spend almost nothing at our store. Or it's a product of the scale we have here. This goes up to 8,000. Some people, on average, spend $8,000 when they come to our store. That's ridiculous. They need to find a better hobby. Maybe they've only come once though, and they bought an ATV, yeah, or the whole family, and they're all about bikes or something. So we have some outliers here, but most people spend just a little bit of $154 on average. But that takes into account those outliers since that's the mean. Wow, that's a terrible box plot. Okay, but that's the way you can begin to understand who or something about the data you have, is going through distributions. Ask me any questions as we go, otherwise I'm just going to keep plowing on. So that's sort of the most basic way to go through it, looking at those distributions. Cluster analysis is a way to profile in a good way. Profiling has a negative connotation, but there's a way to profile your data. If you go to Analyze, Classify, and I'm going to use a two-step cluster analysis, but you can use any of these. They all do different things. I'm just going to talk about two-step because it's the simplest to talk about. Classify, Analyze, Classify, two-step cluster analysis. When you open that up, several options here. We have a place for categorical variables and place for continuous variables. And what this is going to do is it's going to say, what are the naturally occurring groups of people, in my case customers, within this data set? Are like married, young females, old, crusty men. I don't think I have crustiness in there actually. But something like that, we could do it in terms of income and commute, anything. So you tell me, what profiling variables would we like to include?
Those who have children.
Those who have children. So there's number of children, which would be a continuous variable. What else should we throw up there?
Will the scale and total spend be?
Total spending. I want to know who the big spenders are at my store. Again, that's continuous.
Like
Is children really truly continuous? Because
It is short.
you cannot have 1.5 children. So
Neither can you have negative children.
yeah. So
Yeah. So it's not categorical. Yeah, because they aren't discrete values that are unrelated. So anything that is numerically meaningful to increase or decrease is continuous.
Okay.
Yeah.
Gender.
And I heard also, so that's categorical, and bike buyer. I'd like to know who's buying my bikes. Now, beware, bike buyers and gender in this data set only have two values, male, female, or yes or no for bike buyer. Which means if we're trying to see what clusters we have, those are going to be very strong influencers for those clusters because there's only two possible values. We can, of course, force it to make multiple yes groups and multiple no groups, multiple male and female groups, which I think we'll do. But it will be a strong influencer of your classification. Anything else we want to profile people by? Yeah.
What's the third type? I forget. So you have the continuous, the categorical, and so your commute.
It depends on.
So your commute distances.
So that's interval or scale or ordinal, depending on who you talk to. In SPSS, those are called scale, I believe. I'll look actually, because I don't want to tell you wrong. It's right here. Over here, we have nominal, scale, and ordinal. Ordinal would be something like commute distance, where it is roughly equal interval scale. Okay. Anything else we want to throw up there as a profiling variable? Okay, we'll do it again, but here we go. Options, we don't need any options right now. It assumes that any continuous variables will be standardized. Don't worry about that. Output, you can save the cluster membership number. So it's going to assign every single row of my data, all 10,000 rows, to one of the clusters it extracts. And it'll number each of those clusters. This is cluster 1, 2, 3, and 4. And whoever you end up as a customer, it'll create a new variable in the data set and say you were in cluster 1, you were in cluster 2, 5, 7, things like that. So you can actually save right here, create cluster membership variable. We're going to do that later. We can also create those clusters based on the variables we already specified, those 4 variables, but then we can evaluate those clusters based on something else. We won't create the clusters based on this, but we can evaluate them based on something like yearly income or whatever. I'll throw in yearly income, that's easy to understand. Continue. We can determine automatically the number of clusters. Just let SPSS figure out what is the best way to distinguish between these groups. What it's going to do is it's going to create the tightest clusters possible that are the furthest between each other. So those people who are the most similar to each other and most dissimilar to others based on these 4 variables. Or we can say, I don't care about that so much. What I care about is that I get 4 even clusters, or 4 clusters exactly. We're going to let it go automatically to start and hit continue. And it'll think about it, and you end up with nothing. Essentially, it gives you 1 output, which is awesome. What this is a sort of a model fit for those who took the Quant course. It's sort of like a model fit for cluster analysis. This says how tight are our clusters and how far are they in between each other. Is there good convergence in those clusters and good discriminants between them? Now, if you double click it, also I should say it came up with 8 clusters, which is quite a few. But they're pretty good explanations of the customers' profiles because we're in this good range here. Double click it and you get a lot more options. By the way, that's sort of a secret in SPSS. You can double click almost any of the output and it'll let you do a lot of stuff with it. That's something I did not teach in the Quant course. Here are our clusters. Now you can see we have some fairly small ones, 3.6%. And then we have these massive ones. Depending on your context, it might be better to have roughly equal, but then you sacrifice distance between and tightness within. But in an industry like retail, we don't care how big, although we might tailor our advertising towards the larger clusters, or we might seek out more from the smaller clusters.
Is there any significance to the position of the cluster on the pie chart, or is it just totally random?
I'm not sure. Let's see, blue, red, blue. Yeah, it goes clockwise from 12 o'clock. 1, 2, 3, 4, 5 to 8. But what do those mean? I have no idea. We're gonna go find out though.
James?
Yeah.
I got the cluster distribution and the cluster profiles, but I didn't get the pretty pictures.
Really? Okay. Let me come check it out real quick. No, you're fine. I want people to ask questions and make sure it's working. Oh, did you do K-means or 2-step? Let's see, you got all sorts of stuff. 2-step cluster analysis, good. Wow, you got all sorts of stuff. Huh.
But I didn't get the.
No, you didn't.
Maybe I didn't click on something
What
that
version?
asked for
No,
17.
Version 17 of SPSS? That is my guess, that's the issue.
That they don't
I bet this is a
pretty
new,
things in.
yeah. If you have an old version of SPSS, it doesn't do all the pretty stuff. So, Mimi has 17. I think this is version 22 I'm on. Anyone else have a really old version of
We
SPSS?
don't want to talk about age.
18? 18's working? 18 was a big jump ahead for IBM, so for SPSS, which I don't know if IBM owned it at that point actually. Maybe it was 18 when IBM bought it and they changed a bunch of stuff. Anywho, so you can follow along up here, I suppose. Everything you have there though is a table format of what we're going to see. If you go to, there we go. If you go down here to the bottom left, you'll see the model summary. We don't want to see the model summary. We want to see the clusters. Here are the clusters on my really tiny 640 by 480 screen. Drives me nuts. With 8 clusters, we're gonna, okay, we'll work with it. So if I click on the top of a cluster, I can see the distributions. These are kind of hard to read. What I'm going to do instead is I'm going to view these as distributions, relative distributions, which I think I can see. Here we go. I want to see it against everybody else. Okay, this bottom or this left distribution button. If I click on one cell, it'll start showing me the distributions of this cluster versus everyone else. Everyone else is in faded out colors, and then this cluster is in dark red. So in this cluster, no one was a bike buyer. These are my non-bike buyers who have very few children, 0 or 1 children. You can see by this distribution here that none of them are out here. This is the rest of the group, who are all female, who spent, come on, very little relative to everyone else. That's this cluster. So if I were to name this cluster, these are female non-bike buyers who don't spend a lot. I don't know. It's kind of hard to name this one. Let's look at another one here. Again,
They're not moms.
if they are moms, they only have 1 kid. Yeah, but mostly they're not moms. We can just look at this now that we know what these mean. We have few children, males, right here, not bike buyers, and again spent very little. Let's scoot over to the right here. We have the high number of children groups, lots of kids, males. You see where I'm getting at, right? I mean, you can explore your data quite a bit. Now, what I think is interesting, there are some of these groups where there's not a lot of discriminants. I don't know if you can see that very well, but this is one of the small groups, the 3.6% or whatever. There's not good convergence on how much they spent. If we look at gender, there's some male, some female. Over here we have just kids across the board. So at this point we might say, well, what are the what are the variables that are helping us out, and what are the ones that aren't really helping us out? Let's see. Total spent, everybody's spending less. I don't think total spent is a very good variable. You can see it's all distributed to the left, which doesn't discriminate between clusters very well. So not a very important discriminatory variable. Number of children, maybe that works. Bike buyer, that seems to work on the no end. On the yes end, yeah, we have some that are just yes. So what we can do now is we can go back. Let me close this. And it's gonna print out whatever my most recent dialogue was, whatever I was looking at most recently. But I'm gonna rerun that analysis. If you go to this button right here, this down arrow button, it'll show you all the things you've done most recently. I've done a lot of stuff recently. But the 2 steps should be at the top of that. And I'm gonna get rid of total spent because that was useless. I'm gonna throw in age. I think it'd be interesting to see for those males and females, are they old or young? For the ones with children, old or young. And I'm going to force this down to 4. Why 4? Because we have 2 binary variables. We have males who bought bikes, males who didn't buy bikes. Females who bought bikes, females who didn't buy bikes. And those are very clear groups. And then we'll see for them how many children and their age. I'm assuming that's how it's going to distribute it. We'll see. And it says that's still a good way to distinguish these or to cluster this data. The groups are much more evenly distributed. Well, not evenly distributed, much larger, but that's because we only have 4 of them instead of 8. There's a massive group here. Let's go discover who these people are. So again, you go, instead of model summary, look at clusters. And let's look at this distribution here. Let's see if we predicted it correctly. We have not bike buyer, not bike buyer, not bike buyer. Wow, 3 not bike buyer, 3 not bike buyers, and 1 bike buyer group. which is unfortunate because that means it threw all the males and all the females of any age and with any children into a single bike buyer group. So not a very useful classification. The only other thing I haven't shown you with this is the outcome variable. We wanted to see how much people make, but we didn't want to use that as a clustering variable. We just want to evaluate the clusters based on that variable. If you go to display here and click on evaluation fields, yearly income's there. If I hit OK, yearly income will now be included in the evaluation. And it looks like there is not a lot of difference between these clusters based on yearly income. But if there were, that'd be interesting. Or maybe it's interesting that there's not. But you can see how you can better understand, you can classify who your in this case customers are, but it could be your offices you manage or accounts you manage or clients or whatnot. You can better understand your data in this way. Questions about this?
James, how did you bring up the individual distributions again?
Yeah, this bottom left button right here, and then if you click on a single cell, like if I click on bike buyer, it should show up a distribution. Do you see that? Good. Cool.
So,
yeah.
do you think it's not true or true that if you, like it didn't work out on total spend? It seems to me if I was a retailer, that would still be a very important element to me, that if you change the cluster to exclude some things and include some other things, that total spend may become more
different
meaningful in a cluster. Different.
Yeah. So that would be a goal. If I were, the man in charge, and I wanted to find out who are my big spenders, I would have somebody go and discriminate until I can find out who the big spenders are, and then I could
age or by gender. Or
yeah, something, and then you could target them better and say, hey, we're having a sale, having a promotion, come on down. I know you're going to spend because you always do. Yeah.
If they're primarily interested in selling more bikes?
Selling more bikes are probably their big sale item. They're the most expensive in the store for this particular store. And so that's one way to target them, yeah. One more thing on this. Let's pretend we had a good discriminant cases. I mean, these very good discriminant cases. And we thought, hey, these are pretty good profiles of our customers.
How do you measure that the discrimination is significant enough?
Back here, if I go to model summary, right here, this is a measure of discrimination and tightness within. So there's the tightness within the cluster, how closely each of those people in each cluster are related to each other, but are not related to other people in other clusters. And the threshold here is 0.5. What this means, as far as I understand it, is 50% of the, this is going to be a really rough measure here, but they share 50% in common with each other rather than with others. So more is they can explain each other and be related to each other more than they are related to other people. But if you don't have that 50%, well then your cluster is meaningless because it's half random essentially. So you want to break that 50% threshold. Okay, we're going to run this one more time, and this time we're going to save a cluster membership number. As long as we're running this one more time, we might as well try to get a better bit of discrimination. Bike buyer didn't seem to work very well. I'm going to throw that out and throw in average spending. Why not? And force it to 4 and hit OK. Oh, I was supposed to save a membership number. Sorry. Go back to 2-step. In the output, create membership variable. And this is just going to create a new variable telling us which cluster you're part of. So I was in the output, create cluster membership variable. Doing it by gender, age, children, and average spending, forcing it to 4, run. And this is not a very good clustering, but we're going to use it anyway just for example purposes. I'm going to double click this. Yep, we have this really tiny group. Looks like we maybe should have had 3 groups. So I'm going to let it be that way. I'm going to close this, run it one more time, let it run freely, but I want no more than 5. Now, it's saving a cluster membership number. Actually already did. If I go back to my data set and look at the end, this TSC, 2-step cluster number, it created a variable already. Cluster 4, cluster 1. I'm going to delete this because I'm going to use a new one. Run it. Again, if I'm moving too fast, slow me down. That's much better. We're closer to that 50% threshold. It picked out only 2 clusters. That's fine. Double click them. Looks like we have clusters. We have males and females. That's how it broke them up. We have males and females. Average spending looks to be very different actually. Males seem to spend a good deal more, 188, versus females who spend 118. Children doesn't seem to distinguish, and age doesn't seem to distinguish. So those are meaningless, but really it's the spending and the gender. So high spending males, low spending females. If I were to force it to 4, I might be able to break it up to high spending and low spending males and females. But we're going to run with this. What I'm going to do is I'm going to go back to my data, and I'm going to run an ANOVA on this cluster membership number. I'll explain what that does. Many of you are probably familiar with ANOVAs. If you go to Analyze and Compare Means, stop. Before I do that, I'm sorry. I'm going to back up. I'm going to go to Variable View. And in the variable view, you have that TSC, 2-step cluster number. I'm going to rename this to cluster num. And it allows me to specify values in the values column. I'm going to open that up. Right now it says there are outliers. Turns out there might have been some outliers. That's cool. I'm going to create a new one where 1 is, this was males I believe, male, high spender, and then 2 was female, low spender, and now I have 3 groups in this data set. Outliers, males and females. It's not me, right? Mimi, is that you?
That's me. I did something with a variable. It's not. I was trying to rename the variable.
Yeah, at least you're coming.
Not again.
Convergence or something?
Okay.
What did you do?
I was just trying to type over this and rename it. I was trying to.
Now might be a good time for a 5-minute break. It's unrelated to this. I'm going to save this stuff.
Didn't think about it.
See if it closes. Doesn't want to close. Turn off your sound real quick. Oh, it's trying to close. Here we go. Yes. Yes.
We're doing a little bit on with in the SPS program. Look at the just from the module from 110 business 111.
Destroyed it.
And then I think that
I destroyed the output.
so that's
I didn't save it. Oh, I'm sorry. Oh, I'm sorry.
These open the wrong way.
Well, just because it was supposed to be open out.
Oh, I have it on the video.
Yeah. When we get to the credits and
PM, alumni data.
Yeah,
There it
since-
is.
yeah.
There's no longer screaming at you, so that's good.
Thank you very
You're welcome.
much.
I have a question for you.
Yes.
I think bought a new laptop, the old one, the hard drive.
Oh
died.
no. Yeah.
So I have the old license and everything,
Mhm.
but and like I went through this before, where even though I have the license key, I can't start it up.
Really?
Yeah, so
I'm
I was
not.
waiting for again, and I wait for IT, like, but typically what has to happen is I have to contact IBM and then for SPSS, and then they send you this like 200 character authorization code. And
Really?
Yeah.
Oh man, I'm not the guy to talk to
Okay.
you about that. I'm sorry.
That's all right. You're like,
It's not Windows 8, is it?
No,
Oh, good.
no. I had the same before. You're like with my previous laptop, they can really limit the number of PCs that you actually use the license on.
Oh. Thanks.
So besides the license code, you need this authorization code.
Carrying on. We got the beeping fixed. Okay. ANOVA. That's where we're at.
Thank you.
Okay.
I'm not in handcuffs either.
That's right. Okay, so what we just did, recap, we just created clusters and assigned everyone in our data set to one of two clusters or made them an outlier because they don't belong anywhere. And now we've named those clusters as male high spender, female low spender. I guess we could have just named them male or female or high spender, low spender because they're mutually exclusive at this point. And hit OK. And now what we're going to do is we're going to do an ANOVA. ANOVA, I guess, makes more sense if we had more than two groups. But, well, we have three groups, so this does make sense. Go to Analyze and compare means one-way ANOVA. What this is going to do is going to allow us to say, based on this variable or that variable, are these two groups different? Statistically different. So I'm going to go to one-way ANOVA. Most of you should be familiar with one-way ANOVA, although I didn't teach it to some of the older classes or earlier classes.
Better choice of word.
Thank you. I always got to watch myself in the DM program because I'm not that old, you know. And so it's a sensitive topic sometimes. All right, Karen and I are peers though. Okay. Factor. The factoring variable is cluster number. That's the one we just created. So this says separate the data based on cluster number. And what do I want to compare? Whatever. Not one of the variables we used in clustering. So we can throw in yearly income. We couldn't throw in gender because that's one of the variables already. We could throw in
Occupation.
I'd like to know occupation. Occupation is nominal. No, we didn't use occupation, but occupation is nominal. It's categorical. The variables aren't on a scale that means anything when we move up or down it. If I have an occupation that is listed as 5, it doesn't mean I have more occupation than you if your occupation is listed as 2. I don't think ANOVA handles
Education.
It might. I'm going to stick it in there, just play with it. I'm not as familiar with ANOVA. I don't use it much in my work, but we're going to see if it works. Anyone know for sure if I can throw nominal variables in an... No? All right, we're going to find out.
What about the frequency of purchase?
Yeah, frequency of purchases would be very important to know. Transactions is all I have on that, but so number of transactions. Let's stop there. Contrasts, post hoc. We're good. In that case, just hit OK. And here's what we come up with. Not that. Here we go. Down to one-way ANOVA. Here are the 4 variables we wanted to see if these two groups were different on. It's actually 3 groups. Lost. Because of the outliers. So they're thrown in here somewhere. I can show you how to take care of that. But it looks like we are not different at all. Here, if you look at the SIG column, this is a p-value. The p-values are not significant, meaning yearly income is not significantly different between cluster 1 and cluster 2. Either is occupation or education. Again, I'm not sure if occupation actually works in this case. I don't think it does. But transactions are different. Here's why I think. Didn't we use total spending? Total spending is going to be, all things equal, correlated linearly, roughly, with the number of times you come into the store and purchase something. So obviously we're going to be different. interesting. No, or not interesting, I suppose.
I can't see that. Is that point odd?
Yeah, 002. Yeah, 002, which would be less than 0.05, therefore significant to 95% confidence level. But you can see how, think outside of this example, if you had meaningful clusters and you wanted to compare them in terms of number of times they'd come into the store, it'd be interesting to know if there were differences between males or females. You could just use males or females if you wanted. In fact, let's do something like that. I'm going to go to one-way ANOVA again, take out cluster number, and just use gender or occupation. Let's start with gender. Gender is easy. Hit OK. And it turns out males and females are not significantly different in this particular data set when it comes to any of these variables. So do I need to target males and females differently in my advertising? No, at least not based on these 4 variables. One more time, occupation. Where'd you go? I know it's here. Oh, it's up here. Here we go. And I'm not actually interested in these. I want to know if they spent more on average. Number of transactions and average spending. And here's what we get. Hello? What did I thought I used occupation. I did. Yes, okay. Turns out average spending is very different based on occupation. And if I want to know how so, what I can do is go do a Posthoc test. So back to the ANOVA. It was just average spending, so I'm going to get rid of transactions. I don't need that in there. So I have average spending, just separated by occupation. If I go to Posthoc and do, all of these do roughly the same thing. I'm just going to pick the Bonferronis because it sounds like rice-a-roni, so it's fun.
You have kids?
Yeah. But the Tukey's does essentially the same thing as the Bonferronis. All of them, again, do about the same thing. I'm going to hit OK or continue. And what this is going to do is going to say, for each occupation, compare each occupation with every other occupation. Not just as a whole are they different, but how are they different. And hit OK. Awesome, it gave me 1s and 2s instead of actual occupations. I'm going to very quickly go look and see what those occupations are. If you go back to the data set, here's occupation. And if I click on values, values here, we see that 1 means manual, skilled is 2, clerical is 3, management and professional 4 and 5. So essentially working sort of up the occupational chain, roughly, not perfectly. Clerical might go before skilled manual, depending on who you are. So we see that, wow, and actually if you look at the SIG column, they are all significantly different to everybody except, if we're going 95% confidence level, this guy, number 2, which was skilled manual, is not really different from professional. That's interesting. And if we get down here to number 4 and 5 are not different. That's professional versus managerial. Not significantly different in terms of average spending at our store. These are insights you can then base, managerial decisions on. Questions? How to advertise, who to target, how to target them, who not to distinguish between. It really doesn't matter in this case between professionals and managerial. No difference. But there's a huge difference between those guys and clerical.
And the one way is because we assumed there was a directional difference.
Right. Also, I don't know if I had a MANOVA. There's probably a way to do MANOVA. I've never used MANOVA. Again, aerated hole in a golf course. Yeah. My aerated hole is structural equation modeling, which this is not. Yeah. But it is useful, and I know a wee bit about it. So I like to share some knowledge.
So in this case, then would it be more helpful than to actually have knowledge of what people purchase versus what they spend?
Yes. like bike buyers. I mean, we'd like to know who bought bikes and who didn't buy bikes.
Yeah, and then what type, and then so that you can, and then get to your conclusions.
Yes, you can make inferences based on those. Yes, this example is maybe not the most perfect example. It'd be better to find out who's purchasing what. In this case, we only have whether they bought a bike or not. But here, okay, I'm going to follow up on this. Let's go right here. Let's do another ANOVA. Instead of occupation, I'm going to throw in bike buyer as the factoring variable. And see if there's any difference in, not average spending, because bike buying is probably correlated with average spending because bikes are expensive. I'm going to throw that out. But I want to know, is there a difference between those who buy bikes and those who don't buy bikes based on their number of cars? I think there should be. Their commute distance, definitely there should be. And their age. Those three things. And you can target this too. When you're deciding who to target and advertise to, you can target distance from your location and things like that. Distance from the city. Hit OK. Posthoc. Oh, there are only two. There's no bonferonis in this case because there's only did buy bike or didn't buy bike. Whoa. Everything is significant. So this tells me, and oh, I should throw up a means test, or means plot. I'm going to rewind, go back and do that ANOVA. In your options, I think, there's a means plot. This will plot the means of both groups on every variable, which is very informative, I think. If you hit continue, hit OK, we'll see here. Okay, small screen. This is for bike buyers, mean of cars, number of cars. Those who don't buy bikes have more cars. On average, 1.7 cars versus 1.3 cars. So, not a huge difference, but there is a statistically significant difference, also possibly because we have 10,000 rows of data. So any difference is going to be significant. Commute distance, 2.4 and 2.8. The commute distance is funny. It's not number of miles. It's, if you look here, commute distance 2 is 1 to 2 miles, whereas 3 is 2 to 5 miles. So we're somewhere in between those right now.
And then the next category goes up by 5 miles.
Yeah, it's a big jump. And then age, those who buy bikes are younger. 39.5 on average versus those who don't buy bikes are 41.5. If this were real, not fabricated data, we'd probably see some better differences here. But this is purely fabricated, and making 10,000 rows of fabricated data is very difficult to make it actually do some things you want. But this is a way to see who's buying our bikes, who's not buying our bikes. Let's pretend we had bigger differences here. Looks like younger folks are buying our bikes than older folks, and it looks like they tend to commute less and have fewer cars. Makes sense, but now we have evidence to establish that. Any other questions about ANOVA and that sort of thing we've covered? It's fairly straightforward. And now you have a video showing you how to do it. Okay. Automatic linear modeling. I like this. This is good stuff. I don't think any of you have learned this. I have a video on it already, but it was after all of you went through the program, and I don't teach it in the program anyway. So this is fun. It's a new feature of SPSS. Sorry?
What was it called?
Automatic linear modeling. It's a brand new feature in SPSS. It came out with version 21, I think. So anyone who doesn't have version 21 or higher, you can check, but I don't think it's there. If you go to Analyze, and this is really good also for academic theorizing. It's fishing a little bit, but if you're just stuck and you don't know how to predict something, if you don't know what predicts this dependent variable and you got all these other variables and you can't figure out for the life of you how this relates to anything else, you can go to Regression, and the top option in the current version is automatic linear modeling. Who has it on their SPSS? What version do you guys have? 20, yeah, 21 to current one. Okay, yeah. It's just, I think it's 21 plus. Okay.
You should have a certain sample size.
No, I mean more than 30 would be good, but yeah, with 10,000 we're good. Yeah.
I'm just, your own data, it's unlikely.
No,
10,000.
it'll run even if you have just a little bit of data.
So if you have 70 or so, you're.
Yeah, the risk you're running, as always, when you have less data, is greater error, which means lower critical values, which means higher p-values, which means no significance, less power. Okay, automatic linear modeling. I used this once because I was just stuck. Okay, I'm going to throw everything, Control A, throw it all over outside for now. It defaults to predictors. I'm going to throw it all out of my model right now. Or that way, I guess. What is it we want to predict? Unfortunately, automatic linear modeling does not do logistic regression, so you cannot predict any non-metrically meaningful variables. So we have to use a scalar here, a scale variable, or continuous variable. We could predict average spending. That's a good one. Let's throw that in there. What do we want to predict it with? How about just a bunch of stuff? Not those things, those don't make any sense, but age, cars, education, children, yearly income. Throw those in there. You can actually predict it with these other things. Interesting. Cool. I'm going to hit run. It's going to think about it for a bit. It's doing a lot of fun stuff in the background. And again, like the cluster analysis, it just comes up with one plot. But if you double click it, the first thing that shows up is sort of like on that cluster analysis, this how well are we explaining the data? How good is the model? And in this case, it's a terrible model. We cannot predict average spending with the variables we came up with. This is just awful. But we'll pretend it's good for now, for example purposes.
Dependent variable. What is your target? You just pick that at random.
The dependent variable? I picked average spending.
No, I mean, the target is the dependent variable. Right?
Yes, the target is average spending is the dependent variable. The target is, yes. This is the adjusted R-square. We can accept a much lower threshold here than on the goodness of fit for the cluster analysis. Depending on your field, in my field, anything above 0.2 on R-square is fairly decent. In other fields, like I know in finance, it'd be fabulous to be able to explain 4% of change in revenue. I'd love to learn how to gain 4% more or something. That's not exactly what it means, but roughly, I mean, it'd be great to be able to explain 4% of the movement in your revenue. In other fields, anything less than 50% is garbage. So it just depends on your field. I'm going to go here and look at this one. This is the Predictor Importance. This tells me which ones are the greatest predictors of average spending. No surprises here, it's yearly income. The more you make, the more you spend. Number of children. Now, you gotta be careful whenever you're doing something like this. Who typically has more children? Poor people or rich people?
Poor people.
Totally depends. Totally depends on the country, the state, so many other things. But is number of children really predictive of total spending? In this case, maybe. People with more kids probably have to spend more at the store. If one kid gets a bike, they all gotta have bikes. If one gets a football.
In the U.S.
This is U.S. data. No. It's 2/3 U.S., some Europe, some Pacific islands. Yeah. Anyway, again, fabricated. Number of cars. This probably relates to income, though. Number of cars you have. But these are the most important variables in predicting average spending. So do I want to target people with higher income? Obviously. With more kids? Definitely. With more cars? Possibly. I mean, that might just be an artifact of being more well off or having more kids. If you have more kids, you got to have more cars. So pay attention to those confounding effects. We look down here. This is one of my favorites here. Hey, it even has a target for you. This tells us which variables have the strongest effect, what direction the effect is, and how significant it is. Right now I have the p-values of anything. I'm going to make it to a p-value of 0.05, so it's got to be significant, the 95% confidence level. Since we have 10,000 rows, everything's going to be significant at that level. And here's what we get. Yearly income, if it's blue, it's a positive effect. Yearly income is, the coefficient is 0.003, that's unstandardized. So that's hard to translate. Roughly what this means is, for every dollar increase in my income, I will spend an additional 1/3 of a cent at this store. Not a huge difference. But it is significant. Interestingly, the more kids I have, the less I'm going to spend. I theorized the other direction. But that's what this means. Significantly in the other direction. For every additional kid I have, I'll spend 46 less dollars at this store. The coefficient is 46 there. So I want to target people with fewer kids. For every car I have, I'm going to spend fewer dollars. 73 fewer dollars. More educated people will spend more, and the older I am, the less I'll spend. I hope you can see how this could be applied to something in your field. Better, you can really start to begin to better understand your data this way. That's done in the background. So in order to make the data more normal, in order to let the regressions work more validly, it does some transformations, like it cubes them or whatever it needs to do. I actually have a guy who's creating a video on how to transform your data to make it more normal. Hopefully he'll get that done soon, and I'll post that. Did you have a question?
No, I was just wondering if there's enough people interested, if you could just go through some regression and correlations for people with lower numbers of SPSS.
Oh, that's totally fine. Yeah, we can do some very basic linear regression, correlation, just to understand how that works. I'll be brief on it.
So is this in effect doing like stepwise regression and automatic transformation? Which vaguely recall being told is invalid and a bad thing to do, right? Because there's no theory, right? So this is
right. This is what the data tells. This is purely a theoretical. You are correct.
This is how you get your 16th paper out of it.
No. Stop recording. No. What this is a last-ditch effort when all else fails and you can't figure out what predicts this variable, or if you're not a scientist, if you're a consultant, and somebody says, "Hey, I need to know what drives sales." Here you go. This is what drives sales. Yeah.
The difference is this is what drove sales last year in this data.
Yes.
We
don't know if it will next time. We need to theorize about it. Very good call. Yes, and that should be explained as a consultant to the, not that they'll listen, but yeah.
You wouldn't expect it to change that much.
We would hope it wouldn't change, unless it was completely spurious, and then it's, who knows?
Well, it depends on what the data is affected by, like the change factors and like the.
Oh yeah, market issues, environment issues, economic issues.
But at what point?
Seriously.
When you look at the data that you have, at what point do you look at interaction effects?
Okay. Well, at what point do you look at interaction effects? When you're smart, that's when you look at interaction effects. Or when this goes back to theorizing first. When there should be interactions, that's when you look at interaction effects. For those who are having trouble recalling, interaction is not just this affects this and this affects this, but together, so you multiply, there's a multiplicative effect between this and this, such that the effect of them combined is greater than the effect of them separate, or less than the effect of them separate, something like that. If you're smart and thinking ahead scientifically, that's when you start doing that, or if you can't find anything.
Because I mean, for example, number of children and number of transactions. And like,
Yeah.
we would say that
There's probably some interactive effect there. I agree.
Or if you just had yearly income as the independent variable and the average spending as the dependent, but you did an interaction with yearly income and education.
Oh yeah,
you
yeah,
might get bigger.
yeah, definitely. So this also goes sort of to profiling. That's a little bit what we're doing in cluster analysis. We're saying, well, those who have low income but high education, they're this interesting group who made it big without having to invest a lot in their education. And this interaction is very interesting, and it says something about the amount they spend. Yeah. So to some extent, we've looked at interactions with cluster analyses. We good on automatic linear modeling?
So again, that percentage you're looking for at the beginning should be over a certain number.
Depending on your field. Yeah, for my field, it's 0.2. For
Guessing that's 2.9%.
if you're in finance, that's borderline. Yeah, if you get predicting firm performance as a real number, like, price per share or revenues, profits, predicting that is impossible, almost. If you can explain most studies get away with explaining 2%, if I'm correct. I believe it's roughly 2%.
What factors would explain?
To explain movement in actual money,
Yeah.
it's low.
Yeah, I've looked more at performance of portfolios.
Oh, okay.
And so you can, if you've got the right variables,
You can explain a lot more.
Explain more.
Yeah, but in an actual company's performance, it's like 2%. We had a study that did 4%, and the reviewer's like, "Oh my goodness, what did you do? This is amazing." 4%. R-squared of 0.04.
Stop the machines. We're
Seriously,
changing everything.
yeah,
So
it was
that's
amazing.
your R squared is the percentage of showing up on that worst of that.
Yeah, that very first one. That's the R-square, the adjusted R-square. Yeah. Okay. We're going to hit some linear regression and correlations, because there is another way. What we just did is the fancy way to do what I'm going to do now, which is you can just throw everything into a bucket. Oh, let me close this. If you have an older version of SPSS, you can actually just go to Analyze, Linear Regression, or Regression Linear. See all this other stuff? You ever wonder what it does? Me too. I know what some of it does, but not all of it. We're going to talk a little bit about binary logistic, and I'm not actually going to talk about curve estimation. We can, but if you really want to.
Did you use PLS in your? I would think in your.
Yeah, I use PLS quite a bit. I don't use the PLS from SPSS because it's non-graphical. I like graphical interfaces, so I use Smart PLS 3.0. It's brand new. It's funny, actually. Yeah, the guy who makes it, Christian Ringel, he emailed me the other day, a couple months ago, actually, and he said, "Hey James, I love your YouTube videos. Here are a couple licenses." Wink, wink. I haven't made the videos yet, but I need to. Anyway,
Yeah, Smart PLS.
have you tried version 3, the newest? It's a huge leap beyond version 2. It does multi-group analysis, which is great.
But it's the same as SEM, only it's not. Right?
It is SEM. It's a different brand of SEM. There's covariance based, which is like Amos and Lizerl, and then there's PLS based, which is components based, not covariance based, which is PLS, which can run in PLS Graph, Smart PLS, Warp PLS, PLS GUI, XL Stat. There are a bunch of PLS programs.
You've got 3.1.
Yeah.
They're giving away for free their first data.
Oh, really?
Yeah.
It's not free anymore. It's expensive. Anyway, moving forward. Anyway, you use PLS, and for one type of analysis, you use Amos or covariance-based methods for a different type of analysis, mainly based on whether you have formative or reflective factors.
Or sample size?
That was an argument for a long time, but I just published a paper saying no. Like, that was the argument. One of our main arguments in the paper was you can't publish PLS. You can't use PLS you can't justify using PLS because of sample size. Because it suffers from the same errors. The beauty of a PLS is it will run anyway, whereas in Amos, it won't run. Yeah. So, but it runs with the same errors you would experience in Amos if Amos ran. You have higher error, is all. And distributional issues are more influential. When you
I got pushed to review analysis where I had small sample with PLS, which I didn't know.
That's because the reviewers have no clue.
Right,
Yeah.
so I went and did it.
They've heard that it's this magic thing.
Yeah.
No. Anyway, all right.
Okay.
Linear is where we were going. So we're going to do the exact same thing we just did in automatic linear modeling, but without all the beautiful transformations and influence factors and all that. But if you have an old version of SPSS, this works. So we just predicted average spending as the dependent, and we threw in income, children, education, cars, age, not total spent, excuse me. Those ones. And that's it. You just hit OK. I should back up. It's cool if you hit OK, but I'm going to talk about this real quick. You can create a selection variable, which is to say I only want to look at males, or I only want to look at females when I run this analysis. You can do this other ways, but this is one way to do it, by creating a selection variable. All right, okay. Overall, these variables altogether significantly predict average spending. And if we look at this table, coefficients, individually they all significantly predict average spending. And here are those values. Negative for children, like we saw in automatic linear modeling, and negative for cars and age, but positive for income and education. And you see those values are roughly identical to what we saw. You know, for every additional child, you spend $46 less. It's roughly the same as what we saw, and yet these aren't transformed. So almost the same results. But we can also get a standardized version, which I really like. You can see on a relative scale what is the impact of those variables. And that's linear regression. We can also do it through correlation. That's sort of stepping back on the rigorous scale. But you can see linear regression, automatic linear modeling, say all these variables taken together and their interdependent effects, what are their predictive effects? We're going to do a bivariate correlation, which says isolate all these relationships and don't even pay attention to any other variables. And then tell me what are those correlations, which are essentially the same as the regression weight, but not, because they don't take into account all those other variables. But we'll find we have similar effects. Analyze, correlate. I'm greatly simplifying here. Correlate bivariate. This is just going to say, for every variable, what is the relationship with every other variable? And if I throw in average spending and all those other things, yearly income, cars, age, they're all just treated equally. There is no dependent variable, there is no independent variable. They're all just relating to each other. And I'm going to hit OK. And you just get this fancy table. It's hard to read, but essentially you have every variable on the column and on the row, and where they intersect with each other is their correlation. So average spending is this first column, and you see the Pearson's correlation is this amount, and if it's significant, it'll have some stars next to it, indicated level of significance here at the bottom. And it looks like they're all significant, again, because we have 10,000 rows. But the greatest predictor, if we're going based only on the correlation value, is number of cars. Number of cars I have, the less I'm going to spend at this store. Probably because I'm not going to buy bikes, because I have cars. That's my theory. Anyway, that's bivariate correlations. This is considered the least rigorous.
And this is valid for continuous scale, right?
Yes, I would not throw in a categorical variable here.
And if you have categorical, then you use
Logistic, which we'll do next.
or do you use Spearman? But can't you do Spearman at that point of correlation?
I don't know. Do you know?
Well, that's what I've been told. So
Oh.
I use
Cool.
In the tables I do, you know how you have that diagonal
Uh-huh.
when you actually publish one?
Uh-huh.
This is from a co-author, I didn't figure this out, but we did Pearson below and Spearman above. So
Oh.
you end up with a complete rectangle of numbers, right?
I'm going to throw in Spearman, and I'm going to throw in bike buyer.
I mean, you get a value, you
No.
get a Pearson value for gender or something, right? But it's not, I don't think you can interpret it.
Right, what does it mean?
Yeah.
Yeah. But I'd love to know what the Spearman value is. I'm learning at this point, so let's throw in, I'm going to do occupation because it has more than 2 values. And let's see what happens. In untested waters here. So you have your Spearmans on the left here, the Spearman's row. And what does it mean? Here's occupation. But how do you interpret it? I don't know.
This is something I just learned
Cool. I'd have to look it up,
in the
but
last year. I mean, we just did it, you know, because we had data that had both.
yeah.
And we were theorizing about some of both variables, some categorical variables and some that weren't. And my father said, "Oh, we got to do
Huh.
and we got to do it this way." And I was like, "Okay."
Okay.
I was writing the conclusion.
Okay. Cool. I'll have to look into that. But as long as we're talking about categorical variables in regressions, let me show you logistic. Another thing we didn't learn in the DM program. If you go to Analyze, Regression, there is binary logistic regression. One of the most common questions in retail is, are they going to buy or are they not going to buy? What kind of customer is going to buy? What drives people to buy? And the only thing we can do is see who has bought and what do they like. But you can't throw a binary, well, you can actually use binary in regular regression, it's just interpreted differently. But if you had more than 2 values, that'd be multinomial. Forget everything I just said. We're going to do binary logistic regression and use, we're going to use being a bike buyer as the dependent variable. It is not continuous, it is not scalar, it is nominal binary. Whether you bought it or not. That's in the dependent. And now we can say what predicts whether you're going to buy something or not buy it. I'll throw in yearly income. And those things we think affect it. Number of cars, age, commute distance should be in there. Just all that stuff there. Excuse me. And then just hit OK. There are a lot of options we could play with. I'm not going to get into them. I'm going to hit OK and see what we get. Just scroll down to the very bottom. Variables in the equation. We can actually go up a little bit more. We can go to the R squares here, R squared. We don't have great predictive value. These are very low R squares. But in our variables in the equation, we can see that in the significance column, everything predicts whether you're going to buy or not buy, except education. Education has no impact. But how do we interpret this? Buying is 2, not buying is 1. We had 8,999 people not buy bikes. We have 1,000 people who have bought bikes. And it turns out the more children you have, the less likely you're going to buy a bike, as indicated by this negative beta. So as buying a bike is a greater number than not buying a bike in this case, if we have a negative effect, then we're going to have the lower outcome, which is not buying a bike. 1 means not buying a bike. That makes sense. That's maybe 1 is not buy, 2 is buy. So if we have a negative effect, it means relative to all else, we're less likely to buy a bike.
So education has less of a negative effect.
There's no effect essentially because it's not significant. But something like number of cars, as we noticed before, number of cars is a strong predictor of whether you're going to buy a bike. If you have a bunch of cars, you're not going to buy a bike, according to this model, negative 0.317.
How do you explain the yearly income?
Yearly income.
Doesn't have an effect.
Except it's a significant non-effect.
Yeah, it really doesn't have an effect.
Wait a minute.
Really ignore it. That's all right. Yeah.
Now, doesn't that say whether that no matter how much money you have, buying a bike isn't based on how much money you
Except, well, that's what we see from the beta, yes.
have? Yeah.
But from the p-value, we see that there is some significant difference. This one has me stumped. I don't know. I have no clue what that means. It's not the referential category. The constant is the referential category, I believe. I don't.
It could be a discontinuous function.
Maybe it's such a long scale.
Yeah, you just reach a point where whether you have, it's probably tied to transportation need and ability. to
Oh,
pay.
I know what it is. I know what it
You get
is.
to a point you just don't need more bikes.
But also, due to the size of the scale and these not being standardized effects, it is a number.
It's so small.
It's a small number. For every change in income, which is huge, you have a 1 or 0 change in bike buying. So it is there. It's just
So this
we don't have enough
isn't
decimals.
telling us anything. We're not seeing any positive relationship. It's not telling us anything.
Nothing's telling us whether you will buy a bike, but
Right.
a lot of it's telling us whether you won't buy a bike.
So
Now-
if you had, so if you start to have more children, you inherit a bike,
yeah, you assume it.
right?
Yeah.
I mean, that would be my expectation.
And we can also assume inverse. Even though we see all negative effects, we can assume inverse. The fewer children you have, the more likely you are to buy a bike. The younger you are, the more likely you are to buy a bike. So we can assume the inverse on these. Yeah.
So the shorter the commute distance, the more likely to buy a bike?
Correct. The closer you live
Yeah.
to your workplace, the more likely you are to just bike into work, so to buy a bike. In this case, that's the one variable that actually makes sense. Good. All right. That's logistic regression. And you can do it with non-binaries. It's called multinomial logistic, I think it's multinomial logistic regression. I am not as familiar with it, but if you'd like, we can just take a peek.
So you can use logistic regression.
Oops. Stop.
When you have a categorical.
Yeah, so Amos and linear regression in general don't like categorical dependent variables. If I want to predict somebody's occupation, linear regression can't do that. Unless you create a bunch of dummy variables. No, because if it's can't. So you need something like logistic regression. I'm going to again explore into completely untraversed territory to preach about something I know nothing about, which is my basic philosophy in life, and try multinomial logistic regression. This is where you have a non-binary categorical dependent variable, something like occupation. I want to predict occupation with income, with commute distance, number of cars. Where'd you go? Cars. Now, do they go in the factors or the covariates? I have no idea. No idea. So I'm going to stick them in the factors. I'm going to stop there, pretend I know what I'm doing. I'm going to hit OK. Some errors occurred. Fabulous. And you get a bunch of stuff. And are these significant predictors? I see a sig column. I'm going to pretend I know what that means. It's a p-value. And yes, these are significant predictors of occupation. How so? I'm sure this table tells me, but I'm not sure. So, that's to let you know I know nothing about this, but it does do something. I hope that was informative.
Might have to post it on this.
Lots of practical applications.
Oh, tremendous. Notice it was not on my list of things to cover. All right.
But that is new learning.
Yes, trying to learn. My point here is to demonstrate that it is available And there are people who know things about it, and I am not one of those people. So you have learned something.
It's okay not to know things.
Oh, definitely, definitely. I get emails daily, about 20 to 30 emails a day because of my YouTube presence. People are constantly emailing me saying, hey, I don't know you, but I watch your videos. Here's my problem. I feel like a psychologist, a statistical psychologist. It's terrible. And they'll often email me about stuff that I have no idea. And sometimes I'll go look it up because I'm interested, and I figure it out and tell them how they could have Googled it themselves and how I learned something as I did it. And other times I'm just fed up and I say, Google it. But anyway, lots of stuff I don't know.
Just before you go, there's one, just because I've done a bunch of logistics stuff, there's this thing called Probit, which is, it's basically logistics, but what it gives you is a probability of something.
Right.
So depending on what you're trying to predict, sometimes that's useful.
Mm-hmm.
Like in accounting, we're trying to predict whether financial statements are going to be restated or not. So you can have restatement of a logistic, 1-0, or you can get the Probit version.
The likelihood?
Yeah, which is really a likelihood. So,
cool.
So these values give you 20% likelihood of restatement or something. So that, if you wanted to think about likelihood or interpret it that way, the Probit can help you.
Okay. I've never played with Probit. So I could demonstrate my ignorance again if we wanted. No, but there it is. We learned something else. There's something called Probit, and it's useful for understanding the likelihood of outcomes in categorical.
In logistics, basically, it's just logistic.
Logistic regression that predicts probability.
But somehow they transform it so it's probability.
Huh. Interesting. Cool. Okay. Are there any other statistics in SPSS that you are interested in learning, or anything at all? Or if we needed, I could briefly talk about AMOS or PLS. But I have many other things I'd love to do. But this is your thing.
How many here were interested in some AMOS work?
Couple. Yeah. All right. For AMOS, let me just say I have a bajillion videos.
Yeah.
And I think we'll let those suffice, as there are only two who have moderate interest. I have 90 plus videos on AMOS and other things. So for those who didn't go through my course, I'll just show you real quick. If you go to YouTube /Gaskination. Gaskination. Yeah. Here, I'll open it up here. Gaskination. It's just my last name with an Asian at the end. Don't ask.
You created your own name.
That's right.
That's hard.
It's technically only my own Asian.
Right.
Because I have an N at the end of my name.
Right.
I accidentally searched on YouTube. I was teaching model fit yesterday to my class, and somebody said, well, how do I find your video on model fit? I say, well, just go to YouTube and type model fit. It'll be the first video. It wasn't the first video. I didn't think through that properly. So I went and typed it, and in front of the whole class. I go, oh, that's interesting. So model fit AMOS. Well, I'll be the first video. But if you go to YouTube /Gaskination, we're almost at 1 million hits. Woo! Our wiki is up at almost 3 million hits. It's crazy. But there are a bunch of videos. But if you want to search in my channel, there's this little icon thingy, and you type whatever, mediation, without a comma in front, mediation. And here are all the videos I've made on mediation. There are a bunch, actually. Wow, I'm sick of mediation. I've made a lot of mediation videos. Anyway, so that's where you can find AMOS videos if you need them. I'm making more all the time. Okay.
Do you have the data set, so when you go through your video, thank you for sending that one.
I do have a data set you can follow along with.
Do you have a data set you can follow?
Even better. I just submitted a paper to one of our good journals, and I should show you back to here. Okay. YouTube, Gasconage, and it's the SEM series. Hopefully that's clean. Phew. Okay, here's the SEM series. I created how do you never have to look at my faces. This is the only video ever. My face is in it. But there's a whole playlist of 12 videos that takes you through data screening, EFA, confirmatory factor analysis, validating the measurement model, multivariate assumptions, building, just everything, mediation, moderation, interactions, and it takes you through every step from data screening to the end. And I give you the data set, it's on my wiki, and I just submitted a paper last week to one of our journals and said, hey look, this paper goes through the model I go through in the videos. With the data, I give to everybody for free. And so by going through this, it's not a tutorial manuscript, it's a tutorial package. And he was just thrilled. The editor-in-chief was thrilled. He emailed me back and said, this is great, I can't wait to get this through. And so you'll have a paper showing how to write it up, how to reference everything, how to theorize around the model, and it actually goes through a capstone model, fairly complex model. So that'll be a huge reference for the new DM students too, hopefully.
You don't have a one push button yet
for everything? Do capstone? No, I don't.
What's the name of the data set?
The data set is here on my wiki. If you go to StatWiki, if you typed StatWiki Gaskin into YouTube, you probably find it. Let's see, StatWiki Gaskin. Yeah, it's the first hit. And the data set is just on the first page down here in data sets. It's the YouTube SEM series data set.
Okay.
And you can follow along all 12 videos doing exactly what I do with the exact same data I'm using and get the same results. It's been a very utilized resource.
So what's StatWiki?
StatWiki. If you go to Google and just type in StatWiki Gaskin, I'll be the first hit. But don't type model fit. Yeah, bad idea. A couple of us are doing it right now. Model fit. That's right. Okay. All right. So hopefully that's a good resource for you. And if you're interested in PLS, by the way, I just published an article, the one I was mentioning to you about sample size. This PLS article is PLS, when to use it, or when to choose it and how to use it. And it links to several videos on YouTube. The actual paper does. So if you want to learn PLS, that's the way to do it. And I have playlists just for PLS as well. Okay. How are we? My clock is on other time.
10 o'clock.
10 o'clock. We're halfway through? Blast! Okay, go ahead. Let's take a quick break. And then...
Did you think it was later or earlier?
Earlier, I was hoping. Yeah. I have so much I want to tell you about automating spreadsheets. I mean, we could go for 2 days, 3 days. I got a whole boot camp on it. Oh well. Yeah, take a break. Break for however much time you need. Get back here. Hopefully not more than 10 minutes. But are we supposed to have a 15-minute break at 10?
I believe.
All right, come back at quarter after. Thanks. I'll pause this. Okay, continuing the session. We're going to skip past pivot charts and pivot tables. If you really want to learn about those, go to YouTube. And for those in the room, I emailed you something. Okay. Automating spreadsheets. I am both thrilled and terrified to teach this to you. I asked you before, right? Nobody here actually programs in VBA, right? Does anyone here program, period? Yay. Okay, this will be mind-numbingly slow for you. Just FYI. But most of life is probably mind-numbingly slow for you, Mike, so it's all good. This will be exciting then. I'm going to teach you how to program. This is probably the easiest language on the planet to program in because it's based in Excel, which is something all of you are probably familiar with. And so the objects you work with are cells and ranges and selections, and it's fairly easy to follow. I have a bunch of videos too, and I can point you to those. I have a bunch of videos on how to do this, but I'm recording this session as well, so you'll have that as a reference. What is VBA? Let me open up Excel here. Let's see, let's do this one. Here's a bunch of data. Let me zoom out a bit. What is VBA? Let me back up. VBA is the language behind all Microsoft Office applications. Word, Excel, PowerPoint, Project, Access, Visio, all of them are based on this VBA platform language. And that's what they're developed in. VBA, Visual Basic for Applications. And so if you want to customize or automate anything in any Microsoft Office product, you can do it with VBA. They're really nice. This is something I think is just fabulous with Microsoft, is they let you tamper with the code in the platform, and you can change things in Excel. Like, for example, if you don't want some of these buttons up here, or if you want new buttons up here in the ribbon, you can add them. You can have your own tab up there if you want, with your own functions and buttons that do fancy things. So that's what VBA is. It's the program that Microsoft uses to write all their software. They use multiple languages, but that's the one that they let us have access to manipulate things. You would use VBA to automate something. For example, right out of my, or between my master's and my doctorate, I started consulting with VBA. My father-in-law, try to make this a short story. My father-in-law was doing a job for the CEO of the NSA, not the NSA, but the NSA they're an IT repair company. They're all over the US, they're a big company, but every month the CEO, who happens to be brother-in-law's father-in-law, would send my father-in-law this fat spreadsheet with tons and tons of office data from all the offices, I think like 350 offices in the US. And he would pay my father-in-law a certain amount of money to go through and restructure all of it, create a new tab for every office, and get rid of all the data that we didn't care about. And this data was just a data dump from the server, right? And then restructure it, make calculations, format it, make it all pretty, make new analysis fields, and create reports. And this would take my father-in-law days. And when I found out he was doing this, I said, well, do you do the same thing every time with every office? Do you get the same kind of structured data roughly every single time? He's like, yeah, it's just tedious. It takes a long time. I said, well, we can automate that. And so I spent literally like 2 hours, less time than it takes him to do one of these bits of work, to write some code. And all he has to do now is press a button, and in 3 seconds or less, his entire job's done. Life is good. Yeah.
And the bill goes out the same as it did the last time.
Exactly. And so he let the bill go out for 3 more months. And then he's like, I gotta tell him. I mean, it's just too cool not to tell him. I said, if you tell him, you're gonna lose your money. He's like, I know, but it's just so cool. Okay, so he told the CEO, and the CEO was like, oh, that's interesting. I think I'm going to do it from now on. And the CEO is going to press the button. And thank you for telling me. I get a call the same day. Hey, would you like to come up to my office? And I spent a week at this guy's office, going around from desk to desk at the headquarters and saying, hey, is there anything you do in Excel that is tedious? And all of them were like, yeah. Yeah. They had an employee, one employee resource, full-time, devoted to doing a single task. And that was collecting a bunch of data from every office, making map stuff, tons and tons of tedious work. It took me a day, but we automated his task, his entire job. And it now takes 8 minutes to do what he spent an entire week, every week on. every week. His 40 hours now are done in 8 minutes. He still has a job. I actually asked the CEO before I did this. I said, I can automate this, but I don't want to automate this if this means this guy's going to lose his job. He says, no. He's actually my brother-in-law too. So a lot of it's Utah, you know, family. Yeah, that's right. So anyway, we automated it roughly. I mean, it saved them roughly 6 figures a year. I mean, it's great. So I want to teach you how to do stuff like that. I'm going to teach you the very basics because I can't teach you more in this limited amount of time. But you'll be able to then take this back home to your office or to the people you work with, and at least you'll know what can be done, and you'll have an inkling of how it is done, and then you can say to your graduate student assistant or whoever it is you have, your intern, say, hey, I need this done. Here are a couple videos. Go watch them. Figure out how to do it. Automate this for me. This has been the most valuable skill I've ever learned. Period. It has saved me so much time. Let me show you an example. I'm going to show you 2 examples real quick. Here's a bunch of data. I have a big data dump. Control, Shift, and
Excuse me, are you recording?
Yeah, I am recording.
Okay.
I have 1,000 rows of data, nothing essentially, right? You can imagine it's much bigger. It's just a batch data dump of first, last, office, and quarter 1, 2, 3, and 4 sales for salespeople. And I have 1,000 rows of this. But in this format, in columns A and B, sorry, that's kind of small. In columns A and B, that's not a very useful format. I really would like it to be in this format, where I actually calculate their total sales and average sales across the whole year, all quarters, and put their name together. You know, I don't want it to be first, last. I want it to be Ann Hannah. Well, you can automate this. Let me delete this here. Do I have a button for it? No, I don't have a button for it. If I go to developer, most of you won't have a developer tab, I'll tell you to get it. But if I go to the developer and access the programs I've written by going to macros, and just look at the macros in this workbook, there's one called Batch Me. There's another one called Beef Nut, don't ask. There's another one called Batch Me. If I run Batch Me, it runs through all this data, and magic, poof, it made all the calculations for me, and put all the names together for the entire column. I mean, you can imagine doing this for 10,000 rows or 1,000,000 rows. It would take fractions of the time people go through and do this manually. So that's one example. I want to show you a cooler example though. I had my students create projects, and this is one of the projects the students came up with. Very cool. He's a finance student. He said, I want to know all of the liquidity ratios, the profitability, activity, leveraging, DuPont's, for companies based on their tickers, and I don't want to have to calculate those myself. So give me your favorite tickers. Any of them? Huh? GE.
FB.
FB. AAPL. I'll throw it in there. MSFT. Okay, these are your stock tickers. Let's pick 4 for now. You could pick up to 15. I went to do a comprehensive review, and it's done. Here's what happened. It went and grabbed all the data. Did it grab all those? Wait, get data, sorry. Gotta get data first. What it's doing is it's going out, it's having Excel go out to Yahoo Finance, scrape their web pages, bring it all back in, make a new tab, GE, FB, Apple, Microsoft. You can see at the bottom here, these tabs, just created on the fly, named them, brought in all of the Yahoo Finance for the last few quarters, and then in a new ratios tab, calculated all these new measures, and then created charts for them. Let's do a comprehensive review. Here are the charts for them. And it looks like these are in order: GE, FB, Apple, and Microsoft. Facebook has a great current ratio. Fabulous, right? But GE has the most net working capital. Makes sense, right? Anyway, this is all done with VBA. And some student did it after watching some of these videos and learning how to use VBA. Pretty cool. Let's start learning how to use it. So just open up any Excel workbook. It doesn't have to be one I sent you. Just a blank Excel workbook. The first thing we need to do, hope you're excited to learn some of this. The first thing we need to do is get the developer tab. Most of you will not have a developer tab up here. So here's how you get it. If I go too fast, slow me down. We have no agenda for how far to get today. So make sure you get this. You want to go to File, Options on the bottom left. Depending on which version of Excel you have, get to Options. And there will be something called Customize Ribbon.
Customized ribbon?
Customize Ribbon. And it'll be in the video, so you'll be able to see where to point and click. And on the right, you'll see all of the tabs. Your developer tab won't be checked. Check the developer tab. Is anyone who wants to get this not getting this? Okay. If you hit OK, the developer tab will show up now, up in the ribbon here.
Yep.
Get to this point. If you're not to this point, let me know and I can help you out.
Does
Yeah.
this work on Macs the same way?
Yeah, roughly the same way. Yeah. The newer version of Excel on the Mac. The old versions of Excel, like 2008, I think it was, don't have VBA backends. But 2010 and 2014, I think, have.
10 and above.
Is it 10 and above? Have VBA backends. Yeah. Okay. Anyone need more time to get that developer tab? Okay, moving forward. Now that we have the developer tab, we can fiddle. This will be fun. Let's pretend, for example, that every now and then, or every morning, you have to create some, something where you have F name and L name and office, and we could put anything here. You always got to create the same header, right? And it's always got to be bold and underlined, and it's got to be the special font, and it's got to be big, and it's got to be highlighted. I mean, every time you come into the office, you got to do something tedious, right? This is a basic example just for this learning purposes. It'd be kind of a pain in the rear, right, to do this every single time. Why not just automate it? So we can. Let me do that. We're going to recreate this, but instead of, but we're going to record while we recreate. If you go to the Developer tab, and there's a Record button. We're going to hit Record. We're going to name this whatever we want. My first macro. Name it whatever you want. Don't let there be spaces in that name. No spaces. Also, no funny characters like ampersand and asterisks. You can even create a shortcut key for it. Let's do like a Control-Shift. I have a bunch already. I got to remember not to write over one. What are we doing? Header. Control-Shift-H. So I just held Shift-H. Control is default. And this will be the new shortcut key. It'll run this macro every time I hit Control-Shift-H. I held Shift-H, and when my cursor was in the shortcut key area. I can even write a description if I wanted to. Creates header for me, DM workshop, and hit OK. And now it's just recording. It's just recording everything we do. Keystrokes, scrolling, resizing, any actions that get recorded in the history log, anything you could undo or redo is being recorded. Time is not being recorded. I could sit here for a year and it wouldn't record anything. So there's no rush when you're recording. But if I did F name, tab, L name, tab, office, and then I highlighted them and formatted them any way I wanted, make it Batman Forever font and make it bold and underlined. Ooh, put a border around it. Make it all snazzy, orange and black because I'm Batman. and make it real big. There's my thing I have to do every time that I hate doing. It's still recording. And every time I finish, I want it to finish at the cell below it, you know, F or A5. So I've done my tedious job. I hit the stop button back in Developer. There's stop recording. Go ahead and stop it. And now we're not recording anymore. Up in the Developer tab. Now if I clear out these cells, clear out this area, you can select all and hit, I think it's right click delete does it. I made a macro to do it. Which makes sense, right?
Just a second. So after you've got that stuff in here, you go back and how do you do stop?
Stop, you go to Developer tab, and then where you hit record before, it should say stop recording. Yeah. Good, thank you for stopping me. Make sure you get this if you want to get this. Don't let me go too fast. Okay, if I hit Control-Shift, for me it was H, Control-Shift-H, boom. Wow, it stuck it there, that's funky. It's warped, and I'll explain why. But it did the thing automatically. Control-Shift-H. Oh, I know why it did that. Ha! Interesting. Okay. Let me explain. But it did the tedious task. I also wrote a macro to just delete stuff, Control-Shift-X. It's great. We used absolute references positioning when we were recording this macro. We were in A5 or 4. Let me see, Control-Shift-H. We were in A4 when we did this. So every time I run it, it's going to run in A4. Now, if I wanted to run just wherever I am, relative to wherever I am, I would record this with a relative reference, which is almost always what you want to do, unless you always have to create it at the top. Well, then you want it to be absolute. Create it at the top. But for most purposes, we're going to use relative. So check this box in the Developer tab. Again, this just means it's not going to say, oh, you went to E5 and then you went to A3. It's going to say, well, while you were over on this cell, you went to the left 5 and up 2. It's all relative. And that's usually the way to go. So I'm going to record this one more time. Record. Macro 2. A relative macro. I wonder if it'll let me record right over Control-Shift-H. Nope, it won't. Awesome.
Can you delete macros?
You can go delete macros. Yeah. What I'm going to do is I'm not actually going to use a shortcut key. I'm going to create a button to do it for me. So relative macro, no shortcut key. Hit OK, and now it's recording. So F name, L name, office, and it doesn't matter where I am. I'm going to format in my way. So big. How about that big? Outlined, bold, Batman Forever. And I'm going to make it so that they fit. There we go. Super big. Something like that. Format however you want. And then I'm going to finish by going to A1. Control home. That's what I did. Anyway, do whatever it is you want to do to format. I'm going to stop my recording and wait for you guys to get to that point. Anyone still recording? No? Good? And then I'm going to create a button to do this for me. So, get rid of this for now. Control-Shift-X. Okay. And I'm going to insert. This is new, so go to Insert, Illustrations. Illustrations? I want shapes. Where are shapes? I have such a small screen. I want to insert a shape. Usually it's just showing. Oh, here are shapes. I want to insert a button. It could be any shape. I could use a lightning bolt. I could use a smiley face. Go insert a shape.
I don't think.
Can't find shapes?
Nope.
Go to, you see the insert tab?
Yeah, I use Excel every day.
Oh, is there an illustrations tab
Mhm.
or button? And is there shapes in the illustrations?
Yeah.
Okay, we're good? Okay. And then you can include any kind of shape you want. Hopefully something with some width, you know, some 2D value. I'm going to create something that looks sort of like a button. Call it my awesome button, which I can then format however I want. And because I'm kind of OCD, I'm going to format it. Even make it real fancy looking. Sorry, this has nothing to do. I'll stop. We have a button. That's good enough. We have a button. And if you want to right-click your button, you can assign it a macro. Right-click it, assign a macro, and you'll see the relative macro there. Go ahead and assign it, hit OK by clicking on it, and then hit OK. And every time you click on this button, wherever your mouse, whichever cell is selected, will become the default position for wherever that tedious task is going to begin. So I click the button, there it is. F name, L name. There it is. Batman. Yeah? Wherever I am. Just automates that task. Pretty slick. This is a very basic example, but you can imagine you can do much more elaborate stuff with this. Okay, there's more. Yep, here we go. Okay. Questions up at this point? Are we good?
Where do you delete macros?
Where do you delete macros? Control home. If you go to your developer tab, go to the macros button, and then you go to, is it options? I think it's options. Oh, there's a delete button. So you click on delete to delete those macros. I'm going to go ahead and delete my first macro. Yes. You see that delete button? Cool. Okay. Now every time you create a macro, you record something, code is actually being written for you. Excel is writing the code to run that procedure. And that code is hidden back here in the Visual Basic area. I gotta be honest, you guys are doing way better than my undergrads. Just way better. Either you're being shyer about asking questions. I'm recording, so I should be careful what I say. Okay, Visual Basic. I always gotta be careful. I'm always on air, so I gotta be careful. If you open that Visual Basic area, you'll see something maybe like this. If you don't see this, go ahead and double click on, you see VBA Project Book 1. It's probably what you have. Double click or open up the modules box or folder. See a modules folder. And then double click module 1. Yours probably won't say option explicit at top. That's fine. Don't worry about that. But you'll see whatever you named your macro. Everybody got that? No. Okay, let's. Yep, so go to VBA project, book 1, modules, module 1, double click. Okay. Anyone else? Okay. And you'll see, hopefully, the macro you created. Here's the code it created for you. It says inactive cell, go to, or write this value into the active cell, F name. Then offset from where you currently are, and write this thing, and then this thing. And then with all of that that's selected, make it all pretty. And then increase the font. Oh, more. It recorded every single one of those because each one of those is an undoable action. So it records everything you could undo or redo in the history log. So I could actually just delete all this, delete, and just have the last one, selection font size 72. That's all that we really need. Or I could change it. If I didn't want 72, I wanted like 48. I can change it right here. So you can go and edit that code that it creates, which is convenient. Let's say I didn't want, that color I picked. I could change the color, whatnot. And so this is just all formatting, giving me borders, more borders, bunch of stuff. And then it says auto fit all the columns. But this should still run, even though I deleted a bunch of the code, it should still run just fine. And from here you can actually run it. Let me teach you a useful shortcut key for helping us out here. If you hold Alt and then hit Tab, it'll show you everything that's currently running in Windows. If you let go of Alt at this point, it'll switch to your most recently used window, or you could go around and pick whichever one you want.
If you use the Windows key, it's a little cooler.
Yeah, it's true. Windows Tab uses more resources. Come on.
Oh, does it?
Windows, I might have disabled it. Yeah, there we go. Okay, it does use more computing resources because there are images involved, large 3D.
You shut the lights on.
Anyway,
Oh, that's right, we're recording.
it's all good. This is gonna be an informal video. So we're in what, B3. If I go to this macro and hit play, I go back to my sheet. There it is. It's played that macro. Again, that play button's just up here. Let's create our own macro. So I'm going to go to the very bottom of this, and I'm going to start typing. Get rid of this. I need more space. There we go. Every macro starts with this keyword, sub. It stands for sub procedure. Sub, whatever we want to call it. I'm going to call mine Bob. Sub Bob, and hit enter. The VBA will automatically throw in parentheses for you and the closing statement, which is end sub. For those who don't program, which is basically everybody, this is how programs work. You have a start and a stop, and you have a name for your program, and typically you have parentheses which indicate whether or not this program depends on other things. These are called parameters. We aren't going to deal with parameters today. All right.
Fascinating.
Is it?
I programmed in Fortran and COBOL.
Yeah.
Years ago.
Woo!
This is fascinating.
That's
Keep going.
Real programming.
That's
Yeah,
right.
it's
That's
no-
awesome.
But it was the beginning.
There's actually a huge.
Amazing world.
What's funny is there's a tremendous demand right now for Fortran programmers and COBOL programmers. Yeah.
Name your price.
Yeah, pretty much name your price, because we don't learn that anymore, but all the legacy systems are built on it.
Yes, yeah.
Yeah. And so now that those legacy systems are getting outdated and breaking and needing to be patched with all the new programs, you desperately need COBOL programmers. Anyway, okay. So some of this is familiar to you guys. Good, good. Well, let's start with this. How much about programming do you want to teach you, or just show you how to do it? Quick lesson. In programming, nowadays, you work with objects. You manipulate objects, you give them behavior. Objects have properties that you can call and change and read and write. One object that's very common to work with in Excel is a range or a cell. I'm going to use the keyword range. So if I want to write something in B3, I would say range B3. Oops. Dot value equals whatever I want to put in there. Something like hello world. That's right. Copy that down. Range in parentheses, in quotes, B3 dot value equals hello world. I don't know if you can see that from over there, but that's what it looks like. Now, if you type this correctly and there are no typos, what will happen when we run this program is it will go to B3 and it will insert the value hello world. If it works correctly. Let's see. If I hit play, no errors, yay. And here it is, hello world in B3. right there. Piece of cake, right? For those of you who program in other languages, this is a fairly simple language. It's also somewhat forgiving, not as forgiving as like Python, but it's forgiving.
So let me say, does it recognize which workbook was open last and does it there?
Okay, good question. How does it know which B3 to send it to? Because we are in, I closed that project window. Is it Control-Shift-G? I don't remember. Control-R. It's Control-R. Okay. Because we're in this project right now, it assumes we want to go to the worksheets in this project, and then it figures out which one is the currently active worksheet. And for that currently active worksheet, it goes to B3. Yeah.
So what if you want to target a specific?
Okay, check this out. Good. If I add a worksheet, plus this one's called Sheet 2. Let me go back to Sheet 1. This is the active worksheet. But if I wanted to stick something in Sheet 2, I would go like this. Instead of range B3.value, I'd go like this. Sheets Sheet 2 dot activate. And then go to B3. This is the slow way to do it, by the way, but it's probably easiest for teaching purposes right now. And then if I run this, I'm currently in Sheet 1, but it's going to go over to Sheet 2 and activate it and stick it in there. Let me hit play. Hopefully it works. Here we are in Sheet 2. B3 says hello world. I could even at that point go back to Sheet 1 if I didn't want to. I just copy and paste this, change this to a 1, and now I'm going back to Sheet 1 instead of landing on Sheet 2.
So let me bug you one more time.
Yes, please. Bug me a bunch.
So you get multiple files open.
Uh-huh.
How would you locate the correct files?
And let's see, home workbooks. You see how this sort of works, right? Name the workbook, activate. Yeah.
Just in as a sequence, then you have to identify workbook first.
Yep. So it's just a hierarchy. Workbook, sheet, range. Yep. For those who are familiar with programming, I want to show you something. For those who aren't, if you don't get this, don't freak out. But it's fairly simple. Instead of going to the Sheet 2 and activating it, I could actually just go like this. Sheets have ranges, and ranges have values. So sheets have ranges, and ranges have values, and values can equal something. In this case, it's a string. And so I can say sheets 2.range.value equals hello world. I never activated that sheet. I never went there. And hopefully that'll work. Sometimes Excel doesn't like working with ranges. If I go back, let me delete this. Go back to Sheet 1 so we know we're active on Sheet 1. We shouldn't change sheets, period. Let's see if it runs. Hey, it ran. And I go back. I'm still on Sheet 1. I never went to Sheet 2. But Sheet 2 still says hello world. Pretty cool. So it actually uses fewer resources. You don't have to activate different sheets. It just knows where to go and sticks it there. So you see how this is working. Let's do some more. That's just assigning values to sheets, to cells. Let's do more. Let's create a variable. My variables, every time you create a variable in VBA, you have to declare it, which is done by saying dim. Why is it dim? Dimension. Why? Don't worry. Dim variable name. Let's say dim my variable, my var or something like that. You can name it whatever you want. Bob2. My var or dim my var as, you got to declare what this variable is going to be. This variable is going to be a string. String. And you see, VBA is really nice. It pops up whatever you could be doing right now. It says, oh, you're declaring a variable. It could be all this stuff. It could be a scenario. It could be a scene, a server, a shape. But mine's going to be a string. I can just hit enter and it finishes it out for me. So I have this variable. I need to do something with it. I'm going to say that this variable, my var, equals, oops, my capital var equals whatever's in range A1, right? So equals range A1 dot value. That right there. My var equals range A1 dot value. This is going to say, okay, you got this variable my var. Whatever's in A1, stick that, make that the new value for my var. It might change, but for now, make whatever's in A1 the value, or make my var equal to whatever the value is in A1. Right now, there's nothing in A1, so let's stick something in A1. How about James? That's easy. Okay, I'm going to delete hello world over here. So my var now equals James when we run this from the beginning. And I'm going to print out to B3 my var. Instead of hello world, I'm going to print out my var. So now I'm saying range, sheets 2, range B3 is going to equal whatever my var equals. It might change, but right now it equals James. If I run this, I'm on sheet 1, nothing here. Go to sheet 2. This used to say hello world in B3, it now says James. I've assigned it whatever value was in my var. Questions up to this point? Today you've learned about 3 days worth of programming. Just trimmed and consolidated quite a bit. Is it sort of taking root, making sense, maybe? You know, you program though, and then count. It's all basic for you.
Until I decided I didn't want to spend my life with computers.
Yeah.
Okay.
I went to San Jose. Went to the Computer History Museum.
Mm-hmm.
They had a massive. Oh, I don't know.
84.
Yeah.
IBM 84.
It's beautiful. It filled this room. Something like that, yeah. And it itself wasn't the size of this room, but it combined with its printer, combined with its other stuff, filled a lot of this room. It was amazing. It was really loud. Or the air conditioning was really loud. Anyway, so we now know how to use variables, how to give variables values, and how to put those values back out. Now I could also do something like this. Instead of my var equals range a1.value, I could just say my var equals James, in quotes. Anytime you're using what's called a string, just a string of characters that is words, it has to be in quotes, or else it thinks it's a variable. I could also say, I couldn't say my var equals 52. I couldn't say that because 52, my var is a string. 52 is not a string, it's an integer. I could say my var as integer, and then this is totally cool, but then I couldn't say my var equals James. That'd be a no-no. Incompatible. So, 52, 521.
So could you then do data conversions sometimes this way with a macro?
Oh yes, yes. You can do all sorts of formulas. We should get to that, definitely. In fact, let's just do it right now. Let's do some formulas. Let's go over to here. Let's enter some data. How about just throw some numbers in here, 52, 42, 5, 9, 8. Okay, we have some numbers. We go from B2 to B6. Let's say we want to find the total for those. I'm going to stick total, maybe average right there. In C2 and D2. So we're in B2 to B6 is where our data is. Here's what we're going to do. I'm going to say, I'm going to just get rid of all this stuff. Create a new variable called my total, and do another one called my average. Oh, I gotta get into types. An average could be a decimal. Integers don't have decimals. So if we have a decimal, we need to make this a different type. Can't be an integer. It could be a bunch of other stuff. I'm gonna just give it to you. It's gonna be a double. Doubles can have decimals. You don't need to know why at this point, really. Just they're different sizes of numbers, and variables allow for different sizes in memory. An integer only allows for this. I don't know what the number is, but a certain amount of space in memory. I think it's 256 bits or characters, so 8 bits or something like that. Anywho. A long allows longer, a double allows even longer, and a float is whatever, pretty much, big. You can have lots and lots. Do a double. We could say something like worksheet function dot, all one word, worksheet function, and now we can do any worksheet function. Anything you can do in a cell, you can do here now. So let's use, is it sum? Sum. Worksheet function sum. You can stick in as many cells as you want, or we could just give it a selection. So how about range B2 to B6? Do a sum function on range B2 to B6. Make sure you have the right number of parentheses. 2 opening and 2 closing at this point. And then we want to stick that somewhere, right? So back at the beginning, we're going to say that, is it C2? C2 is what we want the total, where the total to come out. So we're going to say range C2 equals whatever that is. Oh, or, sorry, I should do this the right way. I'm sorry. I'm taking shortcuts. You would say something like my total equals that, and then range C2 equals my total, but it has to be in the right order. I'll explain this in a sec. Yes. Thank you. Okay. We're going to set my total equal to whatever that function comes out to, the sum. And then we're going to say, this range is going to equal whatever that value is. This is the cleaner way to do it. It's not the most efficient way to do it, but it's cleaner once you start working with multiple ranges and variables and functions. If I run this, it should work. Hit play. The total is 116. Yep.
So if you go the previous way, record a macro and then go to debug, you'll see the code.
Yeah, if I were to do the sum in the Excel sheet right here, if I said this equals whatever sum, it would record that and do it for me. But instead of doing a hard number, you see here, I only have 116. I don't have equals sum range.
It could sort of pseudo write the code for you.
It would.
Then you can just
Go modify it. Yep, it's wonderful like that. Yeah.
cheat.
It's cheating, yeah. It's great. For the most part, when I code, I just code. But if there's something I don't know how to do, I'll go do what I want to do, but record myself doing it. And then it'll create the code for me, and then I'll just go cut and paste and put that into my own code. It's pretty handy. I'm going to go ahead and do this also for my average. So instead of my total, I just copied and pasted and say my AVG equals worksheet function. Instead of sum, it's AVG, I think. What's that? Maybe. Dot AV, oh, it's dot average. Okay. And instead of C2, it's D2. So this will do both at the same time for me. If I hit play, that'll write them both out. Here we go. Total and average. Did I calculate? That's not the right average. Oh, I said D2 equals my total. It equals my AVG. Computers are stupid. They only do what you tell them. Yeah. So now if I run it, there it is. The average is 23.2. I'll go back, yeah. You're in a terrible spot to see, huh? Okay. All right, so far we've done very, very basic stuff. Yeah?
Would you mind just looking maybe just quickly on my shoulder?
Yeah. Is it not running? Yeah. Cool.
VB7 average. It's because you're setting them equal to those things. We put those. What you need to do is set my total equal to this function, and my average equal to that function. Because right now my total equals nothing. My average equals nothing. Yeah. Well, stick that above. Again, stick those two above. And also say my total equals that, and my average equals that. So just type my total. The variable name. Oh, right. So here we have my total equals. Yeah, there we go. That way you're assigning that variable a value. You're right.
I remember starting to learn programming the first time. It was like being dumped in China with no language training at all, and not in a big city. I mean, just in a village. I had no clue what was going on. And
you have a flowchart template? Draw a flowchart?
huh? What?
Flowchart template? Draw a flowchart?
Is there code that can draw flowcharts? Is that what you're asking?
No.
No.
You do it by hand and draw the
Oh,
picture.
I drew flowcharts first, yeah, and which helped. And
Yeah.
Typically that's how I teach this. I teach them flowcharting first, and then I teach them how to take that flowchart and turn it into code, and then I teach them how to create their own whatever.
There used to be these templates that
I have one still.
Oh, yeah.
would draw the flowcharts for all the different diagrams. So if you had like a data storage or memory or something.
Oh, cool.
You would trace it out so it's pristine.
That's really cool.
In my basement, I'll bring it tomorrow.
Huh, cool. All right. Did it work? Woo! Okay. Trying to think through what I want to cover. We've covered assigning values, assigning ranges, message boxes. Let's do that real quick. Let's do a message box. At the end of this little program, before the end sub, let's say you want to print out a message, or you want to get some information from a user. First, let's print out a message. We'll do something like MSG box. I think that's what it is. Yes, phew. MSG box. And now it says, here's all the stuff I want. Really, all I want to do is say, hello world. So what this is going to do is create a little pop-up that says, hello world. It's that easy. Hit play. There it is, hello world. And you hit OK. It also ran all this other code, by the way. But there's that. If we'd like, we can now do this. Input box. Bunch of things we could stick here. The prompt. What is it we want people to enter? We want people to enter, please enter your first name. And there are a bunch of other parameters we could specify, but we're not going to. And we're going to set this, whatever they give us, we're going to set this equal to f name equals what are the input boxes. F name, which is a new variable I'm creating on the fly. F name equals the input box. Please enter your first name. Might as well create that variable up here. Dim f name as, it's going to be a string. because it's just words. And if I really wanted to, I could say, instead of hello world, hello and f name. I think it's and actually. Hello and f name. Nope, I've been working in another language too long. I don't use VBA as often as I used to. I'm programming an app right now, and I use a different language, and all the languages are different. All right, so the things I added were fname equals this input box. I created a variable called fname, it's a string. And then I'm printing out in a message box, hello and fname. Funny thing about VBA, there has to be a space before and after the ampersand. If I hit play, it says, please enter your first name, Jim Bob. Hit OK, and it says, hello, Jim Bob. You can extrapolate a little bit. I mean, you can do a lot more with this. You have people enter whatever you need from them, and then you don't have to print it out, but you could print it out to a spreadsheet or elsewhere. Okay. How you doing? We haven't had a break in a while. I'm doing great, but how are you guys doing? Yeah, okay. Tell me if you need me. Tell me if you need anything. Stop, break, slow down, speed up. Okay. This is critical. At this point, we haven't saved this workbook. If you go try to save this workbook, it won't let you. Hit save. Just hit, let's see, I'll save it on my desk in the DM Alumni Workshop. If I hit save, it's going to throw me an error. It's going to say, you have code in this workbook. You cannot save this as a non-coded workbook. That's deceiving. It's deceitful, because you could write malicious code and send it to your buddy, and when he opens up this workbook, it automatically runs code and steals all his information and plants a virus. I actually taught my students how to do that, and it was pretty funny.
Oh, wonderful.
Yeah, it was great. Bad idea. I don't do that anymore. I taught them how to create a bomb, a virus, essentially, that opens up Notepad millions of times, and on each Notepad, it continues a message to you. I will kill you in your sleep, or something like that. And that code runs when you open the notebook. And I planted it on somebody else's computer through the network and named it exam key. Anyway, it was pretty rude.
Yeah.
He shouldn't open that file, though.
Exactly.
Entrapment.
Now you know.
Yeah.
Now I know not to open any of your.
That's right. I don't do that anymore. I shouldn't have taught my students how to do that. Anyway, last year, I taught them how to do a DNS attack using Excel on healthcare.gov. It was fun. Okay, sorry. Back to this. You need to save this as a macro-enabled workbook, which, if you go to Save As type, it's XLSM, the second option. Funny enough, my teacher ratings were higher when I taught them how to hack and create viruses. Now I'm just a crusty old man. I'm boring. Okay, so I'm going to save this as exercise or something. Save. Okay, and now you can send it to your friends and they can play with it. Okay. Next, we haven't even touched the good stuff. Navigation. This is important. Okay. Oftentimes, when you want to use VBA, it's because you have a bunch of data in an unstructured way in a spreadsheet, and you want to restructure it, navigate through it, find stuff. Let's just create a bunch of data here. I'm just going to type James, go down a few, is old-ish. So I have 3 cells separated by a bit with some data in them in column A. Let's say I want to make sure I go to the first cell with stuff in it, I copy it, I paste it next to itself, and then I go find the next one. And every time I'm working with this data, that's what I got to do. Is Obviously, you do different stuff, but think of the batch sheet I showed you with all the offices and names and quarter sales. That's what we did. We found the first name, last name, stuck them together, and moved on, and next one next. The way you do this is like this. Let's just create a new sub. Sub navigation. So we actually didn't do much, Martin, while you were gone. We're just going to create a new sub called navigation. And I put a few bits of data in column A, separated by some white space. So James is oldish. Okay. And now we could record a macro, having us do this, control down, control C, control V, control left, control down, control C, control V, control left, control down. I mean, that's essentially the actions we need to take. Or we're going to write a program to do it for us. And then that's what we'll do. Okay. In sub navigation, we're going to say start from home, right? Go home, which is range A1. Oops. Dot activate. That's where we want to start. We have a good reference point going home. But you can start from anywhere you want. And once you get home, go to active cell. That is whatever cell is currently activated. At this point, it's A1. Start from the active cell and end down. Active cell dot end down. So what this is going to do is essentially a control down. It's going to go skip all the white space until it hits a piece of data, and then it's going to stop on that cell. XL down. XL down. It's the first option in the drop down. And I'm going to say dot activate. So from wherever I am, which is A1 at this point, go down as far as you can without jumping over any data. And then stop when you find data and activate that cell. That's my new active cell. Active cell is no longer A1. It's whatever this is. It's A11. And I'm going to say active cell dot copy. There's an easier way to do this. This will work for teaching copy and paste though. That's fine. Okay. Active cell dot copy. And what I want to do is paste it in the cell next to it. So I'd say active cell dot offset, no rows. I don't want to go down or up at all. So 0. One column would be +1, so +1. If I want to go to the left, I'd do -1. Dot paste special. Why is it special? I have no idea. There is no just paste option. It's all special. There's no copy special though. Copying's not that special, I guess. Anywho, and that'll paste it in there without moving anywhere. We're still in A11. And then I'm going to do it again. Ooh, I should write a loop for this. We'll do that in a sec. So I can just copy these three rows again and paste it again and paste it again. And this will do it as many times as I paste it, which is a terrible way to code, but it's good for learning for right now. I'll teach you loops in a sec if we have time. So this is going to go it's going to go to A1, go to control down, control C, control V, control down, control C, control V, and control down. Do it again. Let's run it and see if it works. Play. And it went down to the bottom. Awesome. And it didn't work. You're right. When you paste, it activates that cell. I didn't realize that. So we need to move back. Instead of, we're going to copy this line, and then, no. Sorry. Copy this line, active cell dot offset. Paste this in here. And instead of offset 1, I'm going to -1 to get back. dot activate. Everybody catch that? So we're offsetting back. Because apparently when you paste, it activates. And I'm going to do that for each block of code I created. So now this is the new block of code repeated 3 times. Where did my water go? Is that your water, Martin? I might have.
No,
I think I left it there. Okay. No?
No, I think it must be.
You're right. Let's see. Maintain and activate, and then Excel down and activate, and then copy that Excel, offset that, paste special, and then after this line, hit enter, and you can do active cell dot offset. And you can offset 0, -1.
So you're moving back to where you were.
Yeah, you're moving back to where you were. 0, -1. Dot activate. Sorry. Hit OK. Dot activate. There it is. And then have a pause. At the top pause. Cool. And then if you want to repeat that 3 times, it should do the whole thing. If I hit play, please work. Hey, it worked for me. There it is. How's it working for everybody else? Yeah. Click in here. And click in here. Here, click in and play. And it says object does not support this property or method. Hit debug. Offest. I don't know how you do it. Offset. Yeah. Spelling myself. There we go, and then hit stop. And then, hey, it might have done something. It did, and then you can repeat it 3 times. It'll actually do all of them. Cool. Anybody else? We're good? Okay. Now, we haven't even taught basic structures at all. Conditionals or loops or anything like that. Are we doing good, or do you need a 5-minute? 3-minute? 3-minute? Let's do a 3-minute. 3 to 5 minute. And then we finish soon, so we can't actually take that long. So don't be long. Let me pause the recording here. I hope that's not just deleting everything and starting over.
So then the kid that went out to Yahoo, basically literally went to Internet Explorer.
Yeah.
Into the code for
in the code here, you can do something called, you create an object called an IE object, and it opens up a new Internet Explorer window, and then you give it the URL you want to go to, and then you say, give me all the tables or objects in this page, and it's all in HTML for the most part. Scrape all the HTML, throw it in a worksheet, go find the tags I'm looking for, find the string values I'm looking for and the integers I'm looking for, paste them all in the right place, and then do the math with worksheet function, and then using the new tables I've created, generate some charts. It's a straightforward process that's very complicated, but it's fairly straightforward once you know the code.
For your example, you can pull up the code.
Oh, I can. You want to see the code? Yeah. Let's see. This one, performance comparisons. Couldn't find it. What do you mean you can't find it? Refresh. There we go. Let's go look at the code. Alt F11. Control R. From performance module 1. Here it is. So he has how many modules? He has get data, do an activity, add a name, do reviews. So these are all different sub-procedures that call each other. Grabs the data. Let's see. Ticker. So he just pastes it all in there. I mean, it's a lot of code. Yeah. But check this out. This stuff he didn't write. I guarantee it. He recorded a macro for this web query. And here it is. Here's the URL. And then he just amends to the URL the variable containing the ticker. Yeah. Anyway, it's very clever, but a lot of it recorded probably. And it looks like a lot of code, but for anyone who codes, this is not a lot of code. This is a very small amount of code for that much performance. Okay.
I assume you can go out and Google and find all this code.
Oh yeah, there's so much support for VBA. Tons and tons of support. If there's anything you want to know how to do, Google it. For VBA, not everything. But for VBA, just about everything. Okay. We need to talk about conditionals and loops. And I think that'll about do it for us. Okay. Let's do this. Back to our example of, where was it? The Hello James example, Hello World, where we said give us your first name and then output hello, whatever it is. I'm going to do this. After we get the first name, I'm going to check to see if the name is James. If fname equals James, then it's just English. It's great. I'm just speaking in English and typing it down. If fname equals James, then do something. We need to end this if, end if. Some programs do that for you. This one doesn't, sadly. So I added this end if. Do something. That's just a comment. If you put a single quote mark, it creates a comment. It doesn't execute that code. It's just for your own reference. So we're going to do something. What are we going to do? If it's James, then we're going to copy this message box hello name, Control X, Control V. If it's James, then say hello James. Else, meaning it's not James, we'll say something like, where's James? So this is the new code right here. You can do this with numbers, if you think age or income. If it doesn't meet this threshold, or if it's greater than this, it doesn't have to be equals. You can say if age is less than 20, say hi young pup, or print out something, or create a new variable based on that. Or all sorts of stuff you could do. If the ticker's value is equal to, go to URL this. Conditionals are a universal structure, coding structure. Okay. So this should, if I enter James, say hello James. Hello James. Let's run it again. If I put Bob, where's James? Huh. Pretty easy conditional. Now, that's conditionals. That's it. You could also do this. I don't know how complicated we want to get. I could say if it equals James, message box hello James, else if f name equals Bob. Maybe don't type this part. Just watch on this part. Then, say, what about Bob? And then I can do a final else message box, where is everybody? So this is, if it's not James and it's not Bob, then it's going to say where is everybody. But if it's Bob, it'll say what about Bob? F5 Bob. What about Bob? F5. schmo. Where is everybody? Huh? So it's clever. It understands. It's also stupid because it only understands what we give it. For example, if I say James lowercase, it's going to say, where is everybody? Because lowercase James does not equal uppercase J, lowercase a, m, e, s. Although there are ways around it. I'm not going to teach you that. But there are ways to say just look for absolute no case. That's conditionals. That's easy. There are more conditionals, but I'm not going to talk about those.
How many times can you nest?
As many as you want. And in such cases, you would actually use a different kind of conditional called a select case or switch case, depending on the language. I think it's select case in VBA. I think it is. I just typed it wrong. I've been using this other language, and I use a lot of switch cases in this other language. But if you have a lot of conditionals, use that select case. Yeah. Last thing, I think, is loops. This thing here, where we did offset, paste, we're just copying and pasting code, which is not good practice to just copy and paste multiple times the exact same thing. Bad practice. Instead, we should loop through it. So I'm going to kill the last two pastes of this. Just get rid of it. Home, enter. Okay. And I'm going to create a loop. Something like, there are a bunch of different kinds of loops. Let's do until is empty. Should I do that? That's a bad idea. Yeah, I'm not going to do that. I'm going to start easy. For I equals 1 to 3. Those who code in other languages, this is pretty. So easy. For I equals 1 to 3, do stuff. That's the beginning. At the end of my code here, I'm going to say next. That's the next iteration. Okay. So I say for I equals 1 to 3, do all this stuff, and then do it again until I equals 3. What is I? I is some variable, dim I as integer, that we just use for counting purposes. It's just a counter. So dim I is integer, and I starts at 1 in this case and goes up to 3. And once it hits 3, it's done.
I can see myself punching the IBM cards right now.
That's terrible. Terrible. Maybe you'll appreciate this, Surendra. This is how you do a loop. For I equals 1 to 3. Done. It's great. I love this language. Anyway, this will do the exact same thing. So if I hit play, it ran it 3 times, and there it is right there. Let me delete this just to confirm that it did work. Play. There it is. Boom, boom, boom. Does the exact same thing. So now we don't have to paste it 300 times. We can just say for I equals 1 to 300, do this. We could even do something more dynamic like this. For I equals 1 to 3, do this, do that, copy, paste. Let's make it like this. Excuse me. After we paste special, right here, after we paste special, we're going to say that active cell dot. Let's make this even easier. Sorry. Here we go. Just at the very end, before you next, we'll say active cell dot value equals I. This right here. This is going to place whatever the value of I is in that first cell, because we already pasted it over, right? We have it. We have that value here. Now let's start numbering them. So let's do that. Let me get rid of this here. Okay, and I'll run this. Play, and I go back and I now have 1 James, 2 is, 3 Oldfish. oldish. So it places the value of I. Yep. The only thing I changed was this right here. Active cell dot value equals I.
And you can do this in charts, graphs.
You can throw any code you want into a loop. Any code you want. You can create a chart and then, based on different variable values, create another chart using the same code, just different variable values, different cell references that are made dynamically through relative referencing. Yeah, based on whatever variables you've stored. So a very simple structure like this can do pretty complex stuff. You could even, this is fun, let's create a new sub. Let me blow your mind for a sec. Sub loopy. I'm going to say for I equals 1 to 3. Let's go 1 to 10.
You want to define I?
Oh, thank you. Dim. Hi. Next. Dim I as int. And I'm going to say, again, I'm just going to copy and paste this. Control C, Control V. So for I equals 1 to 10, and then I'm going to say for j equals 1 to 10, I better create a new dim j as integer. I know I'm going fast. I'm going to stop here. Let everybody catch up. There it is. So this is what we call a nested loop. We did nested conditionals. Now we're nesting loops. You can actually nest conditionals within loops. You have to be careful nesting loops, because when you start looping within loops, it's like, I don't know if you guys saw the movie about dreaming, Inception. You have a dream within a dream within a dream. I mean, if we start looping within loops, I'm no longer I'm not doing something 10 times here. I'm doing it 100 times. So if I add another for I equals 1 to 10, I'm doing it 1,000 times. So I got to be really careful about this. And now for I equals 1 to 10, I'm going to print something out like I. How about I print out I? Let me teach you this. Debug.print I. Debug.print prints down to this immediate window. Who doesn't have the immediate window? Good. Oh, you? Okay, hit Control G, I think. Good. Okay. And now I'm going to do the same thing. Control C, debug.print J inside the J loop. So I have debug.print I and debug.print J. And just to make things a little easier, I'm actually going to create some spaces in front of J. So I'm going to say quotes and put a little space in there, just so it adds some spacing. Quotes with some spaces and J. And check this out. If you hit play, let me scroll up here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, and so on. So it's loop-de-loop. But you can do this with anything. I mean, very, very regularly we have loops within loops. Let's say you want to grab all the data in a row and all the data for that row in every cell and do that for all the rows. That's looping across columns and then across rows. So you have a loop within a loop doing all that.
Cartesian product.
Yep. Anyway, last thing I'm going to teach you. Most exciting. Beep. Beep. I should put it in the loop. That'd be mean. Sometimes you create programs that run for minutes, which is a long time in i7 processing time. Minutes is a long time. and Pat, you can laugh at this, I suppose. Minutes is not a long time. But back in the Fortran days, minutes is a really long time. Like I said, I automated a 40-hour job in 8 minutes. Like, that's how long it took to run his 40-hour job. When you sometimes want to know when the process is done running. So I use beep to tell me. I wonder if I have... I do. Cool. So if I run this right now, it didn't pick up my sound. Oh well, but you can test it yourself. It'll beep at you. I'll take this out. Maximum volume. I wish it would like moo or something. That'd be really cool. There is a way to do it. I asked a student if he could figure it out for me. He figured out how to make it moo or burp. All sorts of stuff. You can actually download whatever. I have my email. When I receive an email, it goes don't, or a text message. There are ways to adjust all those things in Windows. So the new beep value is burp. I think that's all I'm gonna teach you. Let me check here. We covered so much. That was a semester, by the way. It really, Blue Angels type overview. Oh, I didn't teach you that. That's all right. That's fine. But we covered so much stuff. We have 5 minutes. I'm gonna teach you one more thing. It's another for loop, but it's a different kind of for loop. So I'm gonna create another one called sub everything. Wow, that's terrible. Everything. That's hard to type. And I'll say dim cell as range. When I was trying to come up with a name, when my wife and I were trying to come up with a name for our most recent daughter, we had a bunch of first names we liked and a bunch of middle names we liked. But we didn't know which ones would go well with each other, so I created a loop in VBA that would say for each first name, and nest it, for each middle name, type out the combination. And it ends up 100 and, I don't know what it was, 48 combinations of names. I didn't have it rank them because that's subjective, but anyway, it was great.
Did you have it also type out the initials?
Oh, I should have thought of that.
Because ended up with the initials ass.
Yeah, terrible stuff. Yeah.
It's,
What are her initials? It's G, D, G. We're okay. Yeah. Yeah.
I mean, one lady I worked with, her initials were JAG, which I thought.
That's great. She named her son Florence or something?
Yeah.
Anyway, okay. Sorry, here we go. Sidetracked. If I have some data like this, B2 to B6, and I want to do something for each one of these cells, I want to do something. I could say this. This is beautiful. For each cell in range B2, B6. That's just great language for anyone who programs. It's just very natural language. For each cell in range this, do something. What do I want to do? Double it. How about that? We'll double it. Double it. That's just a comment to myself. So cell equals cell times 2. For those who program, there is no times equals or plus equals in VBA for some crazy reason. So this is, you're going to take the cell and double it. Let's see if it works.
You need a double it or just
That's just a comment. Yeah, that's just a comment. Yep, so if I hit F5, hey, now it's 104 instead of 52. Let's do it again, F5. Hey, it's 208. Cool, it's working. And now, again, don't forget you can create a button out here or a shortcut key and assign it to that. And then every time you hit that shortcut or that button, it just doubles it or runs that macro. That's all I'm going to teach you. I'm out of time. I'm going to stop the recording and then answer any questions you might have.